Every once in a while, a single idea comes along that doesn't just nudge a field forward, it completely rewrites the rulebook. Well, back in 2017, the world of AI had one of those moments. It came from a research paper with a title that was, honestly, a little bit cheeky. This is the story of Attention is All You Need, the paper that literally laid the foundation for the AI we know today. Before this paper came out, AI language models were improving, sure, but they were bumping against a serious wall. The kind of AI that powers things like ChatGPT today, well, it simply couldn't exist yet. The whole field was waiting for a breakthrough, a new way of thinking. And this was it. To really get why this was so revolutionary, we need to dial back the clock and look at the problem everyone was stuck on. And it all came down to a very basic issue: how computers were trying to read. Okay, so the top models at the time were called recurrent neural networks, or RNNs, and they worked by reading a sentence one word at a time. This sequential approach, as the paper calls it, was their core feature, but it was also their biggest weakness. It was just so slow. And worse, it really struggled to connect a word at the beginning of a long paragraph with a related word at the very end. This right here is the heart of the issue. On the left, you've got the old way of doing things, one word at a time, slow and pretty forgetful over long sentences. What everyone wanted was what you see on the right, a way to process every single word at the exact same time, something fast, efficient, and able to connect any two words instantly. The big question was, how? The researchers from Google Brain and Google Research came up with a solution that was just so elegant and totally radical. They decided to take the old rulebook and just toss it out the window. Their whole argument was sitting right there in the title of the paper. They basically said, you can forget about that slow, one-word-at-a-time process. All you really need is this powerful mechanism they called attention. And the breakthrough concept was this thing called self-attention. The best way to think about it is like a human translator working on a really complex sentence. They don't just read left to right, right? They'll look at one word, then jump back to see what it refers to, then jump forward to see how it connects to something else. Self-attention lets an AI do exactly that, but for every single word in the text, all at the same time. This was the big, risky bet. They introduced a brand new architecture called the transformer, and it completely ditched the sequential processing that had dominated AI for years. Instead, it was built entirely on this self-attention idea, letting it find the relationships between words no matter how far apart they were. So what does a model built only on attention actually look like? Let's pop the hood and take a look. And here it is. This is the diagram that basically launched 1,000 AI startups. I know, it looks complicated, but the core concept is pretty simple. On the left, you have the encoder. Its job is to read and understand the input, like a sentence in English. On the right, you have the decoder, which takes that understanding and generates the output, like the same sentence in German. Now, this is where the transformer's real superpower comes in. The basic attention block on the left, that's kind of like the main engine. But instead of just one engine, the model uses what's called multi-head attention. It's like running a whole bunch of these engines in parallel, as you can see on the right. The original transformer model used 8 of these parallel heads. So what does that mean? It means the model could look at a sentence from 8 different perspectives at the same time. Maybe one head is focused on grammar, another is figuring out who did what to whom, and a third is tracking pronouns, all happening at once. Okay, but wait a second. This brings up a huge question. If you get rid of that one word at a time processing and you're just looking at a big cloud of words all at once, how does the model have any idea what order they're in? The solution was just so clever and simple. Positional encoding. Before any words go into the model, they add a little piece of code to each one. It's basically a mathematical signal that acts like a timestamp, telling the model, hey, this is word number 1, this is word number 2, and so on. Problem solved. So the architecture was brilliant for sure. But the real question is always, how well does it perform? Did this crazy new idea actually work? Well, the results were absolutely staggering. It didn't just work. It completely smashed the existing records. On a standard machine translation test, the transformer didn't just beat the best models out there. It set a brand new state-of-the-art. Now, that jump of over 2 blue points might not sound like a lot, but trust me, in the world of machine translation, that is a massive, massive leap. It's the kind of improvement that makes the entire research community just stop and stare. And here's the kicker.
not only was it better, it was way more efficient. The paper notes that it hit these record-breaking scores after training for just 3.5 days on only 8 GPUs. I mean, that's a tiny fraction of the cost and time of the older models. So it was better, faster, and cheaper.
All right, so let's just quickly recap what made this whole self-attention thing such an absolute game changer. It really came down to 3 huge advantages. First, you could do way more calculations at once, which just made it incredibly fast. Second, it could connect any 2 words in a single step, which finally solved that long-distance dependency problem. And third, it was actually less complex per layer. It was just a win-win-win.
So the transformer was built to solve machine translation. But the researchers, and soon the whole world, realized that an architecture that could pay attention to huge amounts of text and process it all in parallel, well, that wasn't just a better translation tool. It was the blueprint for an entirely new generation of AI. And the rest, as they say, is history.